Hi, this is Greg McKee, Product Marketing Manager and Chief Technologist for LabSphere. This video is a virtual demonstration of LabSphere's UT1000 ultra-tunable source. The UT1000 is incomparable when it comes to spectral radiance matching of any source. The UT1000 is part of LabSphere's spectral image and sensors calibration and test sources.
Hi, Greg here. I want to talk to you today about our ultra-tunable reference light source. This is the UT1000S. It's a side-looking ultra-tunable source. How do we do it? We have a very high-intensity light source here. It gets projected through the system onto a digital mirror. The digital mirror allows us to control the intensity and wavelength. The reflectance coming off this mirror gets projected into an integrating sphere. The integrating sphere allows us to mix that light and then produce a very uniform spectral radiance coming out of the exit port. Now, this system has a spectroradiometer inside. The spectroradiometer inside allows us to monitor the spectral radiance coming out the exit port. The spectroradiometer is used to convolve a spectral target that we want to match to the input to the integrating sphere until they match very precisely. Now, why is this important? With this system, you can reproduce almost exactly any spectrum you put into it. For example, I can easily do illuminant A and D65. Those are easy. But I can also reproduce a display of the spectral radiance of a display. So if we have a display that's an LED display, right? So it has red, green, blue LEDs inside. Now if I can reproduce that spectra from this system, then I can use this system to calibrate all my imaging colorimeters so that all my imaging colorimeters measure the LED displays the same. And all those LED displays will then look the same. Another example is if I'm a display manufacturer and I measure the displays in my laboratory with my high-end spectroradiometer, I get good results. Now I need to field test those field test those displays in the field. Now I'm using a field imaging colorimeter or a field spectroradiometer, not as good as the one in the lab. Those field spectrometers may not even read the same. They might get different results from the laboratory, or they might get different results from each other. With a system like this, you can calibrate all your spectroradiometers, all your imaging colorimeters, so they match the same when measuring that series of displays. Very powerful. There's no other system that can produce the reference spectrums like this. There's no other system. And with this system, it's unlimited how many spectra you can put in. There's no limitation to the number of spectra that you can put in. You can cover practically the full color gamut with this system. Now let's take a look at the software.
And now we're looking at the user interface for the FT1000. Let me walk you through the interface just to familiarize it. This gold line here is the target spectra. So this is a target spectra of illuminant E, so just a flat line, which I loaded, and I'll show you how to do that. And the red line is the spectroradiometer reading. The pink line. This pink line is what the internal spectroradiometer is reading, and it's measuring the spectral radiance through the exit port, and that's what the light source is producing. On the left-hand side here, we have the different illuminants that we can choose from. I just chose illuminant A. It's a pre-programmed spectra. And here is showing the gold is, again, illuminant A, and the pink is what the spectroradiometer is reading. And so we're reading the spectral radiance of the system for illuminant A. This is a pull-down menu, and in this pull-down menu, these are targets that I've created with this system. The system comes with some default spectra, like the standard illuminants, and then also some color spectra as well. As a user, the user can load as many spectra as they desire, and I'm going to show you how to do that in a minute. You can scroll through these just with this pull-down menu. Next is this metric we use, which is A prime. And so A prime is the out of band radiance. And so that would be the difference between what the system is able to produce and the target that we put in here. We're showing a D55 spectra, and we're showing with the pink line what the spectral radiance the system is producing, and the out of band radiance, the difference between the two is less than 2%. On the left is the target performance. So if we go to just, for example, an RGB display, this is the target performance. So based off of this spectra, the gold line, that's the spectral radiance. And then the rest of the values are the color parameters computed from the spectral radiance, which is this gold line. The actual is is actually what the system is producing. So the system is producing the pink line, the spectral radiance, and that is this 1.236 for spectral radiance, and 3.54 for the luminance, and all of these values, the colorimetric values, are calculated from the spectral radiance produced by the FT1000. Down here, we just have a couple of parameters. The band 380 to 730 is what we're calculating the A prime against. So very simple user interface. And over here, we're just monitoring the difference. There's two X's, they're overlaying very closely because one is the target chromaticity coordinates, and the other is the spectral radiance output of the system. So that is, that's the very simple user interface. So how do you load a new spectrum? So let's just go up, let me get access to my bar here. So if I want to add a target, what we're showing here is, I lost it. Let me bring it back. Add delete a target. So here I'm showing this is the maximum output of the system. So it can't produce any more spectral radiance than what's being shown here. If I want to load a target, I can come in this file here. I'm just going to open up a database of targets. So let's just choose one. Let's say 5600K black body. Okay, we could save that. The target spectra format is very simple. It's wavelength and spectral distribution. And that's all it is. And so now all we need to do is tell the software, this is the wavelength column, and this is the data column. We load that up. That's that white line down here. So I need to bring it up so I can get it into the range of this system. So I can auto scale it, or I can, I think it's just, there we go. We'll just do this. You can scale it this way, or you can auto scale it. I think when I was auto scaling it, it was probably maximizing where it was crossing down here. So as I raise this up and down, it's going to match in the region that it can, and then it will not produce light in this area. So this will produce this nice curve in this range here, and that covers the visible range. This can be any spectrum. So let's choose a different spectrum. Let's do something, how about a solid state cool white? Again, wavelength, data, load. And there it is. Auto scale, looks pretty good. If I like that, I'm going to save it, which is use. Solid white. There it is. Okay, I'm sorry. It had just loaded. Just took some time loading it. There it is. That's the file that I just loaded. And now I'm going to tune. And so now it's the spectroradiometer is reading what the output is, which was the last I had it set to, which was the RGB source. And now it's tuning the DMD, the mirror array. It's convolving to what it's measuring, and then telling the DMD to adjust until the spectroradiometer meets the spectral radiance of the target. And so it's honing in on here. And you can see that by this metric, we're watching that it's continuing to improve as it convolves. Now, typically, if you get under 2%, that's good. A lot of systems that are a lot of spectra that are continuous will get under 1%, or much less, under 1%. This looks pretty good. I can continue to wait until it matches even better. But let's say okay, we're under 2%. That's really good. All right, I'm going to stop tuning, and I'm going to save my target. And for this test, we'll do SSL Greg. Give it a name. Okay. Now I can go through this here. I can scroll down until I see it, or I can go here and just go down to SSL Greg, and there it is. Now, if I didn't like that, or I had a bunch of targets in here, and it's getting too much, it can continue to go down as far as you want. You can scroll down. There's the option to go in and delete a file. You don't actually delete it. It goes into a folder which you can pull in later. Very simple user interface. All this data, you can export it. So when it gets exported, you get this information, both on the target and the actual, and you get even more radiometric data. This is our user interface. We created this user interface for our users, but the TCP commands that we use to create this user interface is also available to you. So you can create your own user interface or control of the system. You have access to all the controls that we have.
I hope this was helpful. For more videos on SpectraUT and other LabSphere products, visit us at www.labsphere.com.